Hello, everyone. My name is Gary Russell. I'm the project lead on Spring for Apache Kafka, as well as Spring Integration and Spring AMQP. We started this project a little under well, it's probably in the spring of 2016, and in SpringOne last year, we announced and I gave a talk on the initial 1.0 version, and there's an awful lot changed since then. Some of it driven by changes to the Kafka client itself, and many of these changes driven by community feedback. So keep up the good work and keep giving us those features. As I say, there's a lot happened. You can see there's a lot of versions. The Kafka client itself was, I wouldn't say unstable, but the APIs changed quite significantly in the early days, going from 0.9 to 0.10, and then even within the 0.10 releases, there were some API changes. So, and because of the way our versioning rules apply, we ended up having to create new versions along the way. So even the title for this talk in your agenda is out of date because we're actually at 2.1 already, because shortly after we released 2.0, they released finally the 1.0 GA version of the Kafka client. So the 2.1 release is the latest and greatest. It's based on the 1.0 Kafka client, and we have a corresponding 3.0 version of the Spring Integration extension for Apache Kafka. This is a short 30-minute talk. We're just going to go over some briefly over some of the changes and demo a couple of things. The easiest thing, go look at the reference document. These are the changes between 1.0 and 1.3. I'll explain about 1.3 in just a minute. So initially we added stuff like batch listeners. That was a community request. Null payloads to support compacted topics and deleting entries from compacted topics. In 1.1 to 1.2, that was really just the client change and to support the 10.2 client and 10.1 client, sorry. And then we have other changes, like we added the embedded Kafka annotation for the JUnit test. You can now, the embedded Kafka test broker can now be declared as a JUnit rule. It can be declared as a simple Spring Bean, so if you're using other testing frameworks, you can use it in that fashion, or you can now annotate your test class with embedded Kafka. A bunch of changes to the Kafka listener. We'll look at some of those when we start looking at demos. In 1.3, we're using the Kafka 11 client, and in the Kafka 0.11 client, they added an admin functionality, so you can actually create topics from a Java perspective. You've always been able to create topics programmatically, but you had to have Scala, the Scala jars on the class path, and we kept us sort of strict. We wanted to only have the Java, only have a requirement to have the Java clients on the class path. So until 0.11, you couldn't actually dynamically create topics. We do have the Kafka Scala jars on the class path if you're using the embedded Kafka test jar, but that's only in test scope. We need to talk to, we need the Scala jars for that, but not at runtime for your application that you build on top of it. So we can now create topics, and then in the 1.0 client, you can actually increase partitions on topics. In the 0.11, you can only just create them, and I'll show briefly how we do that. And then 1.3 was to support the 0.11 client, more Kafka listener changes, and some other additional changes. And then finally, in the that was the 1.3 to 2.0. A big push from the community is they wanted to have more control over the Kafka consumer, because the listener container didn't expose the consumer, and so it made it quite difficult for doing things like pausing and resuming. So now in 2.0, you can actually, even in a @KafkaListener method, you can add a consumer argument so you can have some direct interaction with the consumer in your listener. And then in 2.1, which was really, just as I said, that was really just a technology switch to the 1.0 client, but we did manage to get in some additional improvements. So for example, like the RabbitMQ JSON message converter, we can now, and because Kafka now supports headers, we can convey those headers along with the messages that we write to Kafka topics. So on the consuming side, we can interrogate those headers to determine what class or map from the header value to determine what class we want to deserialize to. Before this, you needed a custom message converter or a custom Java deserializer to do stuff like that. And then another big thing that was asked for is the notion of just stopping the container. If I get a Kafka message, I get a message from Kafka, and I don't understand, or I can't process it, and we throw an exception, then just stop consumer, stop the container. So we now have error handlers that you can inject into the listener container that on an exception, it'll just stop the container. And so when you start the container later, that failed message will be redelivered. And we also, in 2.0 and 2.1, there are other error handlers, which we call them seek to current error handlers. So if you're processing a batch of records, and we end up saying, let's say we got 10 records on the poll, and then 5 records in, we throw an exception. We can, if we configure the seek to current error handler, we automatically consume the rest of the messages in the batch, don't send them to the listener, seek every partition to the appropriate place, and then the next poll will redeliver. So you can now have much more control over redelivering messages. So that was always a big issue, that we could handle an error, but how do we get that failed message to be redelivered? You'd have to do stuff at the application level, perhaps with a retry template, or wire in the retry mechanism into the MessageListener adapter. One thing I just want to point out is this KIP. This is Kafka Improvement something. I can't remember what they call them. Kafka Improvement Proposal. That's it. I should have. So this KIP 62 was a pretty significant one for us. In the 1.x line, 1.0, 1.1, 1.2, we had to have 2 threads for each listener, because if your listener was slow to respond, Kafka thought that the consumer was dead and would do a rebalance. He'd basically say, oh, this guy's dead, I'm going to take these partitions off of this consumer. If you didn't call this poll often enough, and of course, if we call your listener on the consumer thread, then we can't call poll because it's in your code, and the consumer's not thread safe, so we can't call this poll, or we can't interact with the consumer in any other way. So we ended up having to have this dance between 2 threads, one that was polling the consumer, handing the messages over to the listener thread, and the consumer thread was having to monitor the listener thread. Does it look like it's taking a long time? And if it did, then send a pause to the consumer, then keep tracking this guy, and when he catches up, then resume. It was pretty nasty code. But it worked, it was functional, but it was not very pretty. And anybody that's written a consumer against one of those older Kafka client jars would have experienced the same thing. It's slow listeners, and rebalancing was just awful. So KIP 62 resolved that. They now, if you want to read the gory details, I briefly showed it in the browser. Just Google KIP 62, and there's a whole treatise on what the issue was and how they solved it. But it was great, because I love ripping out code. So we ripped out a good 40% of the listener container that was dealing with this dance between the 2 threads. So there's now only one thread, which is just the consumer thread. We call your code on the consumer. That enabled us to expose the consumer at the application layer, so you can interact with the consumer yourself, because as I said, it's not thread safe, so you would have to interact with it with that thread that's calling the listener. And the client itself takes care of the heartbeat. So now Kafka is not going to do a rebalance if your listener happens to be taking too long. Now, the original plan was 2.0. This was going to be a 2.0 release, and the 1.x, we'd just leave it with the old threading model. But when we decided that we needed to support Kafka 11 in Spring Cloud Stream, specifically because of the header support, Spring Cloud Stream, we had to do some kludgy stuff with earlier versions of Kafka with embedding headers into payloads and stuff like that. So we wanted to have header support in Spring Cloud Stream with the Kafka binder. So we decided to backport a subset of the 2.0 features to 1.3. Now we couldn't do the consumer aware stuff because a lot of that is based on Java 8 and default methods in interfaces, so that we could have a nice compact hierarchy of listener types that and we using the default methods in Java 8 to support that and make that clean. So we couldn't port that back because we still have a requirement to support Java 7 on the 1.x line. So let's take a quick look at some of these. Oh, wow, it's a lot smaller than I expected. Let me try. Well, I guess I'll probably have to up the font. Let's see. So the first one we're going to look at is this new feature with using the headers to communicate. I'm sure that's way too small. Why can't I make this? Okay, that's bigger. Let me up the font. Small for me, so where's the Java? There's Java. That's too big. Let's try that. Is that readable from the back, or do you want it bigger? Anyone? Okay, so this is a simple boot app. We're taking advantage of some of Boot's auto configuration here. So it's just simple, usual boot main. We have a class MyListener that is annotated at the class level MyListener. One of the new features is that we now use the ID by default as the consumer group. So in the Kafka consumer configuration, the group ID property now gets set to this by default. Because previously, you had to set it in the consumer factory, which meant that all your listener containers used the same group, which was not ideal. And so now we use this ID by default. There are other properties. Oops. There's an ID is group, which is defaults to true to say use the group ID, or you can explicitly include the group ID. But the default property is probably useful for most people, just using the ID as the consumer group. And you can see we have two individual methods here, Kafka handlers. one that handles foo objects and one that handles bar objects. In earlier versions, you really couldn't do that unless you used some kind of a custom message converter or a custom JSON deserializer that knew how to create a foo or a bar and present that to the framework. All we have to do now is configure a message converter. Spring Boot automatically, if it sees a single bean of type message converter in the application context, it gets injected into the Kafka template for publishing messages. It gets injected into the listener containers for decoding objects. Now, the default behavior of this converter is to use, when we have a single Kafka listener annotation on a method, is to actually use the type from the method. But we're in a catch-22 here, because when we decide with a multi-listener bean like this, in order to decide which method to call, we need to know what the payload is. What type of object are we going to do? Well, until we've converted it, we don't know what type it is. So we somehow need a way of doing the conversion first before we decide which method to call. So the default behavior of the message converter is to use the type in the method, but when we're using it in this context, we change this type precedence to say, I want to use this type ID. That just happens to be the name of the header that's containing the type information. And there's recent stuff about CVEs. This was a change in 2.0. There was a problem with Kafka, not Kafka, but Jackson deserializing, the same problem with Java deserializing objects that could do harm to your system. So now we have an opt-in. You have to say what packages I trust. So if you're receiving messages from untrusted sources, you can you can get caught out by that. So this allows you to say which packages I'm going to allow to be decoded. And then these are just a couple of domain objects, this foo and the bar object. So over in the, I don't know what I changed here. Oh, I was just messing with those. Over in the test side of things, all I'm going to do is send a couple of messages. I'm going to send a message with a payload of type foo, and I'm going to send it to this topic, and I'm going to send them both to the same partition so that we see them in the same order. And the only other thing to show is the properties. Say I'm using pretty much all the default boot properties. The only thing I'm doing different is setting this auto offset reset to earliest. This is often the case with when you're using the embedded broker. A lot of times your test will start sending messages before the listener container has started. So what we're doing here is by setting the auto offset reset to earliest, then when the consumer starts, it's going to start fetching records from the beginning of the log, not the end, because latest is the default in Kafka, unless you explicitly, and I'll talk about this max poll records in a minute. That's for the other test. There, we're using a property placeholder to get the address of the brokers, because I'm using the new embedded Kafka annotation on the test case, where it's going to be, so we're going to create this embedded Kafka broker with this one topic, and it's going to have 10 partitions on it. So it gives you some flexibility in setting up your test topics. And if I run this, should be simple enough. Sure enough, we actually got the string representation of these foo and bar, because when I implemented the domain classes, I did the toString. So let me change that font. Console. I need new eyes. So yeah, so we received those two. Where's it gone? Oh, yeah. So we received the two objects that we sent. So this gives us the ability now to have multiple JSON representations sent to the same topic and be able to decode them in the appropriate fashion. Now, you don't have to have a foo and a bar on both sides. You can have any type compatible object, and then you can configure the type mapper to actually map. So if I get the inbound is the key is foo, then I want to create my foo rather than his foo. But as long as the data are type compatible, then you can use that. The second thing I want to show is that this now you have access to the consumer object itself. So now we have this listener again, and instead of just taking the foo object, it has a consumer parameter, and I also pass in just for yucks, which partition was this message received from. This is a method level Kafka listener now. Now, one of the problems, so what I do is I'm just saying every 5 messages, I just do this, I just pause the consumer. I just say, pause the consumer for this topic every 5 messages. The problem with that is if you pause the last last partition, then you'll never get another message, so you'll never be able to resume it again. So the technique we use in that context is we also implement Application Listener with this that gets a listener container idle event. This is again another configurable element to say I want to get application events if the container goes idle. Because the container could go idle just because there's no data, or it could go idle because you've paused all the partitions. So in our OnApplication event now, we can actually go query the consumer, because the event contains the consumer object. All this is all running on the same consumer thread. So we can query the consumer and say if we have any paused topics. We've got an idle container. Do we have any paused topics? And if we do, then we resume them in here. And then we've just got some logic to say if we got a listener container idle and there were no paused consumers, then it's just end the program. Message converter doesn't need to be this complex now because it's a single one, but I just copied it from the other one. The only thing I had to do was add my own Kafka listener container factory bean, because Spring Boot currently doesn't expose this idle event interval to enable us to resume the topics. So I actually opened an issue against Boot for that, to add some of these new properties to the Spring Boot auto configuration. So I'm confident that those will be in place when Boot 2.0 ships. Boot 2.0 is already uses Spring Kafka 2.1. And in this case, let's go. So the test for this one basically just says it's going to send 40 messages to this topic across a couple of partitions. So this time I have 2 partitions in my topic. I'm sending messages to one topic or the other alternately, and then it just sleeps for some time. So we can see this in action. And so now we see we pause we got 5 records. We paused the partition. We got 5. Then we got 5 from the other partition. We ended up pausing it, and then we can see the idle container is being resumed because we find we had paused partitions, and then finally we shut down because we're idle and there are no pause partitions. One thing to be aware of, though, is you'll note here that we got 5 and we did a pause, but we still got another message here from partition 1. That's because if you noticed in the, we go back to the code, in the application YAML, I said max poll records 6. So give me 6 records at a time. That means Kafka is going to give us 6 records, and give the container 6 records. We give them 5, and then the listener says pause the consumer. The pause doesn't take effect until we drain those messages that were returned by the poll. We don't try and do anything sophisticated by, seeking and all that stuff. It's just we're pausing the container. Anything that's still in the tank is going to get sent to you, and then the consumer will pause at that point. So that's pretty much all I had. Are there any questions? Yes, sir.
Something about allowing certain package to
Yes. Well, if you work for com.ibm, right, and you want to allow all com.ibms to go through, you can do that. You can provide a pattern of packages. It's just the thing is there are some open source classes that were found to be vulnerable for running user code. Some Apache Commons something. I don't know exactly what. I don't remember what. So the idea of having a whitelist of classes or packages, packages that classes live in that are permitted to be deserialized from JSON. No, that's something you would configure. You say, I'm talking to a known entity, and they're always going to send me classes in this package. If I get a request to deserialize a class that's in some package that I don't or that the converter doesn't recognize, then it'll refuse to deserialize it. So you have to opt in to say which packages are acceptable. Well, there's two things. By default, the sending system sends the fully qualified class name in the header, and that's the default. But you can also set up mappings. You could say on the sending side, if I'm going to send a.b.c.foo, then just send the key foo. And then on the receiving side, you can map foo to def foo. So you can do mapping so that the actual type doesn't have to be in there, but enough information for the consuming side to know which class we want to deserialize the JSON to. Yes, sir.
How do you reset the offset? Let's say you have option of earliest or the newest, but I want it to go somewhere in the middle.
Well, you can either seek the consumer. You can directly do a seek on the consumer. We also have a and this has been there since 1.1, I think. We have an interface called Consumer Seek Aware. If you implement that, then see this on partitions assigned. You get access to this consumer seek callback where you can say seek to beginning or seek to end or seek to specific offset. So you can either, and then there's this register seek callback, which was kind of a kludge that we had in the early versions that's not really needed now because now you have direct access to the consumer. So if you're actually you want to do a seek at runtime, then you can do that. Yes, sir. Yes. Oh yes, yes. Yeah, it's just a Kafka broker that we fire up. As I say, you can configure it as a JUnit rule, or just declare it as a bean in your application context, or you can use that annotation. And it does stuff like, as I showed in the properties file, it uses a random port because particularly in on CI systems, you can't guarantee that a specific port's going to be available, so it uses a random port, and then it populates this system property so that you can, in your test cases, you can get the runtime. And you can also, if you do it as a, there's a test. So if you actually add it as a rule, like, oh, that's not what I want. You can do stuff like get broker addresses, so you actually get the list of broker addresses. You can do it programmatically. You can get the zookeeper connection. So if you actually want to talk to the embedded zookeeper that this broker's using, you can do that. If you want to manipulate stuff directly in Zookeeper, you can do that too. Yes, sir. Yes. Yes. So in 0.11. In 0.11, and don't have the source on the class path. Let me see. Let me see if I can open the clients here. So the consumer record now has a headers property, and the headers it's just a collection of header properties that you can then add. They're not very sophisticated. They're not like they're just basically string key byte array value. Now the Spring integration project. Actually, Spring integration. No, in the header mapper here, we actually allow JSON encoding and decoding in a header mapper as well. So if you actually want to put a foo as a header, we'll encode that into JSON, and we add an additional header that contains type information to say the header name foo is of type ABC foo. So we added a bit of sophistication. I mean, it's still not a be-all and end-all, but it's a level above just a byte array. And the type information, that the JSON serializer and deserializer and the converter, they just put the class name or the mapping in a byte array. Any more? All right, thanks a lot.